Good morning, good afternoon, good evening, depending on where you're dialed in from. We want to first begin by thanking you for joining us. For the next few hours, we're going to be spending some time discussing tuning SQL Server 2012 for SharePoint 2013. It's a jump start. We're broadcasting live from here in Redmond, Washington. And I'm joined here in the studio with Bill Baer. So it'll be the combination of him and I that we're presenting today. Myself, I'm actually located in Scottsdale, Arizona. I enjoy golf. It's one of the main reasons I moved there, although I don't play well. I do enjoy the game. I've been working in the IT industry for several hundred years. I actually got my first certification, MCSE certification, with Windows NT 3.5, and then have maintained my certifications since then. I've been an MCT since about 1997. For those of you who are MCTs, the renewal process is in effect, so don't forget to do that. I'm going to apologize in advance for the glare off my 5 head. I requested some powder, but that wasn't applied, so the cameramen have put sunglasses on, so they're safe, but for those of you watching remotely, you may have to do the same. If you want to follow me, I'm on LinkedIn, as you can see here, and Twitter as well, as my handle is Brian Alderman, and I do some blogging. Don't peek out there now because I'm in a transition period, and you won't see a lot out there about blogging. As I said, I'm not alone in the studio. I also have Bill Baer joining with me. Welcome, Bill.
Thanks, Brian. I'm Bill Baer. I'm a Senior Product Marketing Manager in our SharePoint product group. On a day-to-day basis, I oversee all of the aspects of our IT professional audience. Prior to coming to Microsoft, I was with Hewlett-Packard in digital equipment and Compaq by virtue of acquisition and merger. And I'm going to go ahead, turn it back over to Brian. We're going to get started on this module, try to keep us on track and keep us on time.
All right, folks, so as you can see here, we have 4 topics we're going to be discussing today. We're going to take a kind of level the playing field. What we want to do is make sure we're assuming we've got SharePoint admins out there who are advanced. We've got SQL Server DBAs out there who are advanced. We want to make sure that we level the playing field in the first module. So for those of you who are SharePoint admins, we're going to take some time and just introduce some basic SQL Server concepts and make sure you have an understanding as we talk and introduce terms and discuss these terms throughout this presentation, that you have an understanding of what we're talking about. So we're going to do that in the very first topic. We're going to go in the second topic. We're going to discuss some of the best practices for the database settings. There's some options that we can configure inside of SQL Server which will optimize what your performance is going to be in your SharePoint world. So we're going to discuss those, and then we're going to give a demonstration on what those configuration options are. We'll move into the third topic, which is our SQL Server settings. As we're going to see here shortly, we're going to kind of drill into your mind that we want you to have a dedicated server or instance of SQL Server for SharePoint. So we'll talk about that and some changes we can make on that instance of SQL Server that's hosting your SharePoint environment. And we'll wrap up with some common problems that we've encountered as we go through the SharePoint world. Ginormous transaction logs is one example. High availability is another example. And then we'll wrap up that module with some best practices. So that's going to be our approach as we go through these next 4 hours. Again, thanks so much for taking the time to join us today. So what we want to do first is set the expectations. And again, we expect some people out there to be advanced SharePoint admins, some people to be advanced SQL admins, but maybe not have a crossover what the other person does. Now, one of the rule of thumbs I have, and I've been in the DBA world as well as the SharePoint world for several years, is get to know your DBAs. In fact, I take my DBA to lunch once a month. Fortunately, I am the DBA and the SQL admin, so I just put it on the business credit card, and I take myself to lunch. It's a one-sided conversation, but I enjoy my alone time. So what we're going to do here at this point is we're going to talk about the SharePoint admin and get them an understanding of what SQL is all about. So as they're going through and having these discussions and these lunches with a SQL Server DBA, they have a good understanding as to what they're referring to. Now, some expectations or prerequisites, I should say, are you may want to take a look at some of the hands-on experience options that you have available with a Microsoft Learning Partner as a preferred method. Also, there's a couple courses. There's course 10774, which is querying Microsoft SQL Server 2012. And there's also another one, 10775, which is administrating Microsoft SQL Server 2012. We're focusing on 2012 because that's the latest and greatest SQL Server product. Although don't forget, we can use SQL Server 2008 R2 with the SharePoint 2013 product. But we want to lean you towards SQL Server 2012 for some of the extra features and benefits and improvements that were made in the SQL Server 2012. And one of those we're going to talk about is always on. We're going to introduce that in Module 4. Now, if you haven't joined the MVA community, which is the Microsoft Virtual Academy, feel free to do so. This is free online learning tailored for your IT pros and your developers. We already have over 1 million registered users for that. We're going to try to get additional ones for you to be able to go out and access up-to-date, relevant training on all Microsoft products that are out there. So it's going to give you the ability to access this environment. In fact, being you have joined us today, what you're going to be able to do is hit that link at the bottom of this slide here, or jot that down, and you're going to get 50 MVA points for today's event. So it's 50 points for today's event. You're going to need to enter in that code SQL for SPJS. So it's SQL for SharePoint, JS is for Jumpstart. That code's only valid through 3/31/2013. So I'm going to pause just a few seconds for you to jot this URL down. Jot that code down and take a few moments on one of our breaks today or sometime after this session this afternoon, and be sure to register for that and get some points for this event that you're attending today. Okay, let's dig into topic 1. Topic 1 is key SQL Server and SharePoint server integration concepts. These are going to be roughly 50 minutes. Please don't hold that to our feet to the fire with that time frame. We're going to keep them around 50 minutes, break for about 10 minutes. Some may run a little bit longer, some may run a few minutes shorter, but overall we'll wrap up at noon Pacific time, as was seen on the registration page when you registered. But in this module here, we're going to talk about SQL Server instances, the database files associated with SQL Server, and we're going to talk about what's called a checkpoint process, and also we're going to introduce us a recovery model, or the concept of a recovery model, but we're going to focus more on that and why that concept of a recovery model is important. We're going to drill into more detail on that in Module 4. So, module agenda, SQL Server deployment options and database types. What we want to do is avoid RPEs. And if you are in the SharePoint world or the SQL Server world, an RPE is a resume producing event. As an administrator of either SQL Server or SharePoint, we want to always constantly keep that in the back of our mind, is to avoid a resume producing event. So even the deployment of SQL Server could cause you, if not deployed correctly, or SharePoint could cause you to have to rip and replace the R&R, not the R&R we're used to with the rest and relaxation, but rip and replace, and we want to avoid that. So when you look at deploying SQL Server, we want to make sure that you deploy that in the best situation possible. We're then going to talk about the integration of SQL Server and SharePoint. We'll talk about some of this schema, and the schema is just kind of the blueprint of what is going on with the databases and with SQL Server that's hosting your SharePoint content. And we'll walk through some of the database descriptions. There's several descriptions or databases that are created when you install SharePoint in SharePoint 23. But we're not going to go through every database, but we're going to hit some of the key 7 or 8 databases. And at the end of the module, you're going to see that we have an appendix with the remaining database descriptions. We'll talk a little bit about I/O with each of these databases, as well as scaling up and scaling out when we're in those database descriptions. So the first thing we're going to begin with is SQL Server deployment options and database types. And what this is going to talk about is the fact, just as a DBA, you're going to know this, but as a SQL Server, as a SharePoint administrator, you may not be aware of the fact that a SQL DBA can install SQL Server or multiple instances of SQL Server on a single physical server or virtual server. So what we want to do is keep in mind that if a DBA is hosting a SQL Server environment that's handling your line of business applications, your LOB, you still have the opportunity to be able to ask them and work with them about installing an instance of SQL Server specifically for SharePoint. Now, when they do an installation of SQL Server on their server box, normally the first instance is called the default instance, and then they can install many other instances which are now called named instances. So what we could do is ask them to install an instance of SQL Server 2012 on their SQL Server box and name it SharePoint. That way, as we're installing our SharePoint farm, as we're communicating with the SharePoint environment, we'll be able to reference that. Now, again, what I want you to do is get a dedicated instance of SQL Server just for SharePoint. We're going to be going through several configuration options today. By the end of this session, this course this afternoon, you're going to see why it's important for you to have your own session. And that's why it's good that we have some SQL DBAs online, so they'll see why it's important for them to allocate a special instance of SQL Server for SharePoint.
Yeah, and I think that aligns to our general recommendation of having a dedicated instance for SharePoint. Largely, when you think about SQL Server and how paramount it is to SharePoint as a whole, some of the things that you need to be aware of or make your DBA apprised of is really disk performance. One of the things that you can never compensate for is poor I/O performance. So in other cases, you could have the opportunity to add CPU or add RAM, but poor I/O performance can really influence overall performance across your farm. So, one of the general recommendations we make is not only having a dedicated instance, but really benchmark that instance. And from a benchmarking perspective, you have a number of things that you can do. SQL I/O, of course, is one of the preferred methods to do that. But generally, what you really want to do is get the fastest response possible from your I/O subsystem. So it's, more disks or perhaps faster arrays, but it's really providing sufficient I/O operations and minimizing latency. And we have some general guidance on TechNet in terms of what kind of latencies you should expect or you should try to work towards as you think about optimizing your SQL Server instance for SharePoint.
Now, you said SQL I/O, Bill. Are you, when it comes to the SQL Server machine, are you more concerned about I/O, or should RAM be an important factor as well?
I think it's a combination of both. I think I/O is one of the fundamental units that you should really plan for, largely because SharePoint is a platform that provides many workloads. So SharePoint can be used for a number of different things. You have the opportunity to have enterprise content management or records management scenarios within the product, as well as core collaboration, all within a single, perhaps, web application. So now what you're looking at is you have databases that are very read-intensive, and then you have databases that could theoretically be very write-intensive. So I/O is kind of that fundamental piece that you should plan for, and then work your way up from there and start thinking about CPU and RAM. But it's generally not that memory intensive in terms of on the SQL backend.
Okay. Now, one of the other things you mentioned too is about having, talked about the dedicated instance. One of the things, the challenges your DBA may be concerned with is like, well, I might want to host SQL Server on, server 1 right now with your named instance of SharePoint, but down the road I may need to move it to a SQL Server 2. So one of the things your DBA can create through the configuration manager inside of SQL Server is an alias, and it's very important for them to create that alias up front. So it's a SQL Server alias, and then as we're referencing content through the SharePoint environment are referring to that SQL Server instance, we don't need to worry about what server and what the instance name is. They're going to give us a nice, easy to remember, easy to use alias, and we'll be able to utilize that throughout the implementation of SharePoint.
Yeah, and I think one thing that's tended to happen in the past is people have looked at aliases as an approach to database mirroring, but it's not a technology that is an aspect of database mirroring. Of course, it can be complementary if you're using mirroring. Obviously, our connection strings changed in SharePoint 2010, so you don't necessarily have to use aliases anymore. But the big benefit of using an alias is, suppose you have two machines, SQL 1 and SQL 2. You can create an alias called SharePoint, and then if you ever refresh those machines, move to different hardware, move to a different storage subsystem to where your instance names will change, whether default or named, you can always just update your alias. So it provides a very simple mechanism to migration.
So alias is one big thing that that a lot of people overlook, so we want to make sure we focus on that. And we talked about having multiple instances of SQL Server on a server, but the thing that you should know is your DBA is not going to be overwhelmed with trying to have 14 different interfaces because he's got 14 different instances of SQL installed. There's one common interface they use, and they can choose to go in and manage each of those instances separately. Even though if there's 14 instances, you still have a single interface that they have to work from. The other thing you do have to keep in mind, though, is that machine, especially if you have 14 instances, probably exaggerating a little bit, hopefully you don't have that many on one server, but each of those instances is sharing that physical server resources, all about the RAM. So if I've got 32 gigs of RAM, I've got 14 instances of SQL, let's even take it down to 4, they're sharing that amount of RAM that's on that physical server. And the CPU is also affected by the number of instances that you have installed. So it can't be in one machine that's got 14, 40 instances of SQL Server, unless it's a really super duper machine. But you got to take into consideration as a DBA, I can install multiple instances on SQL Server. I do want one specific for SharePoint, and it's an easy interface because it's the same interface. I just choose what instance I want to utilize. But I do have to keep in mind, the more instances I add to that server, I have to be aware of the CPU resource and the RAM resources and take that into consideration. Now, I'm going to go in and show you this a little bit, but as we're installing each of these instances of SQL Server, each one of them has what are called default system databases. There's 4 system databases for every instance of SQL Server. There's a master database, and that's kind of like the config database for SharePoint. Everything I do, if I go out and I add some additional databases or some locations for my databases, that's stored in my master database. All the configuration information for that SQL Server instance is stored in my master database. As a SharePoint admin, you're not too concerned about that one. The MSDB database, that's more for your SQL DBAs as well. That one contains information like jobs and operators and alerts, and the replication, where they're replicating content between, if you're using log shipping. So that one's more of your SQL Server automation that your DBAs are going to be using primarily for automating their tasks. So if they want to perform a backup of your SharePoint database, they don't need to wake up at 2 o'clock in the morning to kick off that backup. They can actually schedule that through SQL Server. So they'll use that, all that configuration option and information is stored in the MSDB database. Now the ones that we are concerned about are the TempDB database and the model database.
Right. And I think the way to think about the master database, at least to put it into context of SharePoint, is SQL Server's master database, it could be seen as a parallel to SharePoint's configuration database. That's one of the ways that you can think about what master is. And then obviously the ones that we'll be talking about today largely are TempDB and model, as we're focused on SharePoint as a core portion of this topic. So moving from there, we're going to work our way into the user databases. So you have 2 different constructs. You have system databases and then you have user databases. The user databases are comprised of those databases that the application creates by virtue of an administrator creating either a service or a web application or just instantiating a server farm. So we have web application databases, largely referred to as content databases. Then we'll talk a little bit about service application databases, and then we have some other non-system databases to discuss as part of the core set of this module. We won't cover every single database created in a typical SharePoint installation, so what we'll do is we'll walk through some of the most compelling or important to think about from a planning perspective, and then in the appendix we'll also have some that you can look at following the module.
Okay, understanding SQL Server and SharePoint integration is our next topic that we want to drill down into, because that's what we're here for primarily, is to understand why am I so concerned as a SharePoint administrator, why am I so concerned about what SQL Server guy is doing or gal is doing, and from the SQL Server DBA side, it's like, why is the SharePoint admin so adamant about having its own instance of SQL Server for SharePoint? So we're going to spend a little bit of time talking about this integration. So out of the box, you need to know that 93.8% of all your SharePoint content is stored in SQL Server. Now, how do I know it's 93.8% of your content? Because 76.9% of all statistics are made up on the spot. So that 93.8 is a little bogus, but I just wanted to let you know that a majority of your content is stored in SQL Server, minus some of the configuration settings that you'll create or manage in IIS or in DNS. Your farm configuration information is stored in the config database in SQL Server. Your central admin content is stored in its own content database in SQL Server. Remember, that one has that, if you do the graphical user interface to perform that installation, that one's got that huge GUID, or GUID as Bill calls it, on the end of it. It's this ginormous letter, numbers combination that's stored on the size of Texas, that's stored in the end of the DBA, or the database that was created for the central admin. So just kind of keep that in mind. There is a way to be able to rename that. I've got the steps available to you, so if you email me, I'll be happy to share those with you, and you can actually rename that so that the central admin content database doesn't have that huge GUID on the end of it.
GUID.
Most of your service applications have at least one content database. There's only one or two there's only one I can think of that doesn't, but most of them have at least one. CERTS in 2013 has 4 databases. The UPA user profile application has 3 databases. So you have a ton of databases that are created, a lot more than what we had in previous versions. Specifically coming from SharePoint 2007, we had a half a dozen to 8 or 9, and now your DBAs are looking at this like, man, every time you do a full farm installation, we've got 20 some odd databases that are out there. So there's a lot of databases that are installed, and that's why, again, is one of the reasons we want you to have your own instance of SQL Server so you can manage those databases. All your web apps, as Bill's already pointed out, have at least one content database. We're going to talk through in a future topic or session this morning as to why you may want additional databases created, so for a specific web app. And the bottom line is we want to have a maximum size of a database for performance and for backup and restorations. Now, if you do create databases, there are a couple different ways we can do that. We can create them from inside a SQL Server, or we can create them from inside a SharePoint. One of the things that's unique about SQL or SharePoint is that it has a very unique collation setting, as you can see listed on the bottom bullet here. It's Latin 1, general, case insensitive, accent sensitive, comma sensitive, and width sensitive. That is a requirement for SQL Server. Okay, so for SharePoint's in SQL Server. So we want to make sure that collation setting that we create, we can actually during the installation of that dedicated instance of SQL for SharePoint is utilized during the installation. Otherwise, every time I create a database from inside a SQL Server that's going to be used for SharePoint, I need to specify that collation during the creation of the database. Let's avoid that hassle by having that as a default collation setting when we install SQL Server that's going to be dedicated to SharePoint. So that's one big tip that will allow you to make your life easier and your DBA's life easier by choosing that collation setting during the installation. Now, your farm has several databases that we already talked about. It's over 20 databases if you do what I call a spousal installation. I don't know if anyone's ever done a spousal installation. There's not a recommended way to do an installation, but a spousal installation is when you sit there and you say, okay, 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 and that's how you perform the entire installation. You haven't really chosen anything. You haven't customized everything. It's just a standard, okay, I'm going to click through, hit okay every time until the installation is completed. If you do that, including the farm configuration wizard, you're going to have more than 20 databases that are installed. So we got to be careful about that. Again, another reason for us to have a dedicated instance of SQL Server for SharePoint. Now remember, a site collection can only reside in one database, but a database can contain many, many site collections. All right, and by default, there's 5,000 settings is the maximum number of site collections in SQL Server 2012 with SharePoint 2013. But if you do have a site collection that's larger than 100 gigabytes, isn't it recommended, Bill, for us to kind of isolate that?
As you start working your way into larger and larger site collections, you need to think more and more about isolation of those site collections, and there's a number of reasons for doing that. Predominantly, the reason you want to isolate your larger site collections is because it provides the most simplified opportunity in terms of backup and recovery. So as opposed to trying to use, whether you're using our APIs, whether you're using Windows PowerShell or the SharePoint command line tool, STS-ADM, largely you want to avoid those as you start thinking about 100 gig site collections or even beyond. You really want to use SQL Server's native backup and restore capabilities. It's going to be faster and much more efficient to recover that site collection in the event that something happens. So you want to look at an isolation opportunity for the larger site collections. Now, below that bullet, we also talked about a soft limit or a boundary. So in SharePoint Server 2010, we made some changes in terms of our database capacity. Moving from 2007 to 2010, we increased our capacity from 100 gigs per content database to 200 gigs per content database. With the advent of Service Pack 1 for SharePoint 2010, that 200 gig recommendation still exists, but it exists solely as a recommendation. And really what we've done is we've moved to being able to support up to databases or up to 16 terabytes per database. So for core collaboration, high impact type workloads where you have a lot of read-write activity, or you have a very distributed workload, you really want to look at that recommendation of 200 gigabytes. If you're doing records management, it's largely or predominantly read activity, so say 80-20 read-write, you can look at 4 terabytes and beyond, 16 terabytes being the absolute maximum in terms of a content database. The reason it is 16 terabytes is because we limit you to a single file group with SharePoint. So we don't have the opportunity to create additional file groups with our databases, so you're relegated to a single file group, and from a single file group's perspective, 16 terabytes is about as far as you're going to scale within that file group. So that's kind of where we're at with that. So 200 gigabytes is a recommendation, but you can scale up to 16 terabytes. We have guidance on TechNet. If you look back towards the SharePoint 2010 guidance, that will help you decide what's appropriate for you. Obviously, as you increase the size of your database, your management strategy is going to change quite significantly. Backup and restore times will obviously increase. Database maintenance operations become more and more imperative, and we'll talk about some of those today. So 200 gigabytes is really that safe set to where you can still achieve moderate SLAs using typical backup and restore solutions such as SQL Server, backup and restore, or SharePoint's backup and restore, which obviously calls SQL Server in order to perform those operations. As you move into the 16 terabyte range, you really need to look at disk capacity differently. You need to think about backup capacity differently, and then you need to think about how backup and restore is really going to map to your RTO and RPO once you start getting to databases of that size.
Now, 16 terabytes being that's a maximum limit, that's going to kind of be difficult for you to store all the music that you've obtained over the several hundred years, isn't it?
Right.
I know you love music, so. All right, but inside it, so we're talking about managing the size of the database. The cool thing is that we have control. We don't have to bother our DBAs all the time about the size of our about our databases, because we can create quota templates inside of SQL or inside of SharePoint and assign them to a web app. And we can also set up a maximum number of site collections to make sure that we don't exceed. So we don't need to bother our DBA and say, hey, could you make sure this database doesn't exceed 200 gigabytes? We actually have the opportunity to, by using a quota template, a default quota template for a web app, and setting a maximum number of site collections in on a database, we can control the size of that database to make sure it doesn't exceed that 200 gigabyte soft limit that Bill was just referring to. All right, let's take just a minute. We're going to jump in for a demo here and take a peek at the SQL Server Management Studio and take a peek at some of the concepts that we just introduced to you. So I'm going to jump into my desktop here and find my image somewhere in here. And inside my image here, I'm going to bring down the application manager. You'll see that I've already opened SQL Management Studio. And if I open up databases, you're going to see the 4 system databases that we just introduced. Here's the master database. I'll give you a little bit better view in the right. Let me throw some details up so it's not blank screen. So here's our master database that we talked about. Here's the model database. We're going to come back in the next module and take a peek at how we may want to tweak the model database. Here's the MSDB database that the jobs and the operators and alerts, the automation process that your SQL DBAs are concerned with, and access and update. And here's the TempDB database. And again, TempDB is really, it's a temporary work storage area. So if you're out there slicing and dicing content and it needs to store that while you're doing a search, or while you're doing a sort, I should say, it needs a temporary work storage area to store that. So what it does is it stores this in the TempDB database. And we'll see in the next module some areas where we may want to, some modifications to that we may want to make sure that we have optimal performance if we are doing a sort or a filter of content. You'll see underneath that I've created some service applications. You'll see my search service application has 4 databases, and you'll see that I used the GUI to create them, or the configuration wizard to create them, because they have those huge GUIDs, for Bill's purpose, on the end of them. All right. However, I can create the search service application, and by doing so with PowerShell, now I have control over the names of those databases, so I don't have to control or worry about those GUIDs/GUIDs. Here's the SharePoint admin content database. When we install SharePoint using the graphical user interface, we don't get a prompt there to ask me, hey, what do you want to call your content database for your SharePoint admin content? Well, it gets a huge GUID on the end of it. We're going to switch back and forth between GUID and GUID so people understand, because I don't know how many people use GUID and how many people use the GUID, but I want to keep it fair. You'll see here now below that we have our SharePoint config database. All right, so here's our SharePoint config database. That is the key database. If you lose this database, your SharePoint farm, well, pretty much you've bought the farm, because the SharePoint config database contains all of your configuration information that you've controlled. It contains information about your IIS settings and your solutions. So if you lose this, you're in what I call deep doo-doo. So what you need to do is make sure this is constantly back up, and I'm sure your SQL DBAs are doing so, but you want to make sure that you are monitoring that and making sure everything's backed up. So I just wanted to kind of show you real quickly, these are the databases that you're going to have for your instance of SQL Server dedicated to SharePoint, and as you add service applications and as you add content, or like portal, here's my portal content database, as you add additional content databases to your web applications, you're going to see some additional databases showing up in here. And as we'll talk about a little bit more in this module, we've got several databases just out of the box that we're going to be able to accessing. So just a brief tour of what SQL Management Studio is all about. Let's go back into our slides. I remember how to use my desktop here, and we'll jump back in here. And we're going to go into a schema overview. Remember, I kind of mentioned the word schema. It's really just a blueprint of what the database looks like. So we're going to discuss here some different components of the schema and the database structure and a few restrictions that we've encountered in the real-world environment here in SharePoint 2013.
Yeah, so one of the things that we're going to discuss, at least today, is as we work our way through the next 3 modules throughout the course of this morning, what we're going to try to do, at least this morning from a Redmond perspective, but what we're going to try to do is walk you through just some of the basic schema elements of a SQL Server user database. So we're not going to be very explicit towards SharePoint, but as you have conversations with your database administrators, you need to fundamentally understand what some of these concepts are. So we're going to start kind of at the very beginning, or at the smallest unit of representation when you think about a database, which is the page. So a page is basically the fundamental unit of data storage in SQL Server. So all of the space that's allocated to either an MDF or an NDF in a database is really logically divided into pages, and they're numbered contiguously from 0 to any given number. So let's say from 0 to n. All of your disk I/O operations occur at the page level. So from a storage perspective, SQL Server reads and writes to whole pages. From a page sizing perspective, pages are always 8K, and they can be index or data related. They could be large binary objects or binary large objects, or however else you want to refer to blob, unstructured content versus structured content. So when you insert a record into a table, from a SharePoint administrator's perspective, you create a new list item. A list is obviously just a table within a database. So what you do is when you insert data into a table, they're placed on a page. So you can think of a page as a slot where data is contained. You can only get so many rows within a page, and if you exceed the row length, SQL needs to expand the rows in order to make room for that change. So if the data received is larger than expected, SQL is going to start expanding rows in order to make room for that data change. Now, in the event that it can no longer make room, SQL will divide that onto the next page, and that's what we call a page split. So think about a page as a fundamental unit of storage in SQL Server where all of disk I/O operations are performed. And from a sizing perspective, those pages are 8K. So from pages, what we do is we move into what we call an extent. An extent is a group of 8 physically consecutive pages. So now what you're talking about is 64K. So extents are always aligned against a 64K boundary in 8-page boundaries. So starting at the beginning of each data file, extents and all of their properties are exactly the same depending on the version of SQL Server you're using. So if you look at the illustration we have on the screen, what we have is we have 8-page boundaries, or otherwise 64K, or an extent. In this example, what you see is a simplified kind of representation of a set of leaf pages that contain keys and an intermediate index node mapping the leaf pages. So this is fundamentally what SharePoint would look like if you really dived into the schema. And obviously, when you think about SharePoint schema, we really want you to think about it as a black box. So moving from there, so we've talked about pages, which are 8K. We've talked about extents, which are consecutive 8K pages, or 8 of which, so that's 64K. And now we're going to move our way into kind of some of the content database basic tables. And I'm going to go ahead and turn it over to Brian, and we'll talk about that for a moment.
Yeah, so what's going to happen, you're going to discover this when you drill into the next module, and I kind of briefly talked about it in this chapter's or module as well. We have that model database. That model database has a huge impact on what how SharePoint performs. So we're going to tweak that in the next module or topic. But what you want to know is that every time I create a SharePoint database, it's going to take all the tables that currently reside in a model database, and it's going to, in addition to that, it's going to add these tables here, as you can see, as to hold content that we're going to be using for specific to SharePoint. So for instance, your all user data, that table holds all the information about all the list items for each list. So every time you enter anything into information, into a list, an item, an event, a calendar event, a task, that's actually stored in a table called your all user data. Your all docs, guess what holds that? All your documents that you store. So if you go to a document library or any type of library, all your documents are stored in there. Your features holds information about activated e-features for each of your site collections or your sites. And I'm not going to drill into each and one of these, but just to let you know, if you're looking for information about a site or a site collection or a list or a library, I'm not saying you should go out and modify. In fact, I'm saying absolutely do not modify these tables, but you can actually view these tables for that type of information. So these are just the basic tables that you'll find in a content database that was created from in SharePoint to hold SharePoint. Now, the database structure, as we're going to see, really first off, we're going to create a database from inside of SQL or from inside of SharePoint. Again, if I create it from inside of SQL, I need to make sure that my DBA that creates it uses this collation setting of Latin 1 general, CIAS, KS, and WS. It's already done for me automatically if I create it from inside of SharePoint. So if I create this from inside of SharePoint, I'm not too worried about it. But if I create it as a DBA, then I need to make sure I choose this collation setting in the event I didn't choose it during the installation. Now when I create a database, it actually creates a couple different data files for me. It creates a data file called an MDF file. I only have just one of them, and it actually creates a log file. So every time I create a database, it creates a data file, a .mdf, and at least one LDF file, which is a transaction log file. We're going to introduce what that transaction log does with the MDF as we go through this presentation today. Now optionally, I can create an NDF file. An NDF file allows me to expand on the MDF file. So maybe I create an MDF file on a drive, and the drive is getting low on space, or I want to be able to separate some of the content out, some of that's historical versus some of that is more interactive, OLTP versus ILTP, OLAP versus online transaction processing versus analytical processing. We can create an additional file, which would be an NDF. So every database I create for SharePoint has an MDF file and has an LDF file. We can create additional LDF files. If we want to extend the MDF file, we can add additional NDF files, but I can't add another NDF file or MDF file.
Right, so if you look at the diagram here that Brian has on the screen where we talk a little bit about data structure, we kind of started at the very beginning, or the lowest common denominator when you think about a database. We started at the page level, again 8K, we moved our way into extents, 8 consecutive pages, so now you're at 64K. We talked about tables, and now we're talking about actual data files. A database unit is really comprised of a collection of tables, and the tables is what Brian showed you in the earlier slide, particular, or at least related to SharePoint. So now we've moved our way all the way down to the database unit, and we talk about a collection of tables. And within those tables, you have columns that are designed to store specific types of information. So unstructured content is stored differently than structured content. Structured content could be the metadata associated with a document, whereas the unstructured content is the actual document or the blob itself, the binary large object or the large binary object, depending on how you'd like to refer to it. Beyond that, tables also contain indexes. An index is really the easiest way to think about an index, and in the SharePoint world you've probably heard a lot about indexes, reorganize your indexes, rebuild your indexes, defragment, a number of different ways. Thinking about an index, really an index is no different than any other book or reference material. Basically what it does is it helps you find a specific row of data. The easiest way to think about an index is a phone book is a great index. So if I want to look up Brian Alderman, I immediately flip to A's and I work my way down the A's and I find Alderman. When fragmentation occurs, and a little bit later in these topics we'll talk about rebuilding indexes, reorganizing indexes, but effectively what happens is when Brian Alderman's inserted into my table and there's fragmentation, Brian is inserted, say, under the J's. So now I have to go through all the Joneses to find Alderman. Obviously from a data lookup perspective, that adds time to the actual operation itself because things are no longer contiguous. They've become fragmented. So rebuilding or reorganizing the index within a table will actually return Brian Alderman from Jones back to the A so I can look him up quicker. So I always use the phone book analogy as I think about what an index is. As you think about some of the schema implications or some of the perceptions, at least around SharePoint, a lot of the perceptions are really that SharePoint's tables are too wide, that they wrap rows. Basically what a wide table is, it's a table that has a defined column set. Wide tables use sparse columns, particularly in SQL Server 2012, to increase the total number of columns that a table can have to 30,000. And then the indexes and statistics are also increased from 1,000 to 30,000. But the maximum size of a wide table row is about, let's just say 8,019 bytes. Actually, that's what it is, so we won't even say about. So from a performance perspective, some of the other things to think about as well is SharePoint manages its own name value pair, indexes. Using DBCC with data loss is not supported with SharePoint, so from a data loss perspective, SharePoint is very reliant on transactional consistency. So when you apply a cumulative update or a service pack or a public update, we're very reliant on the schema being as is. And if you use DBCC with data loss, obviously that schema could change fundamentally, which could result in issues later on down the road as you try to apply cumulative updates or service packs. And then lastly, one of the other perceptions is there's really a missing set of integration solutions from a backup and restore perspective. So obviously SharePoint does provide backup and restore capabilities. Some of those capabilities make a direct call to SQL Server. SQL Server implements the backup, and then conversely, when you restore, SharePoint calls SQL. SQL performs the restore, and SharePoint reads from it. Search and other service applications are handled a little bit differently. Obviously, there's a SQL element, but there's also an element of backing up its configuration and any file system attributes with that service application. One of the things that I wanted to answer real quick is there's a student out there asking if it's appropriate from an Azure IaaS perspective or infrastructure as a service perspective, if I'm going to use SharePoint and SQL Server in Azure infrastructure as a service, does that fundamentally change my capacity planning or my performance planning metrics and statistics as I think about it? So from an Azure perspective, we're not going to spend a lot of time on Azure, but what I would recommend is if you visit the Virtualization Resource Center for SharePoint, we have guidance. There's a set of 3 separate white papers. They're also available via windowsazure.com specific to SharePoint that will help you from a capacity and performance perspective as you think about deploying in Windows Azure, for example.
So there are some constraints on the schema. So because of the way SharePoint operates and communicates with SQL Server, and they're listed here. And there's actually what I would like to refer you to is the link on the bottom. Some additional options that you want to be aware of. And when it comes to, so a lot of people get tempted to modify. Hey, I want to go in and modify this table inside of SQL Server that's dedicated to SharePoint, or I want to add new procedures, or I want to make some modifications to our database schema. You don't want to do that. But this article is that we're pointing to on support.microsoft.com/KB841057. Pretty much don't do it, and these are the reasons why. This will give you more information. So if you're tempted, as Bill just pointed out, a service pack comes out or a cumulative update comes out, and you've tweaked those tables thinking, oh, it's just a minor update or a minor change, and then an update comes out, and it clobbers that change, and everything, everything's in chaos.
And this is one of the fundamental things that you need to make your DBAs aware of. So if you're a SharePoint administrator and you have a separate DBA that actually manages your SharePoint infrastructure, DBAs will largely look at databases and they'll find something that they figure they can optimize. Perhaps I'll add an index here, or I'll add a column here, or this column seems to be unused, so I'm going to go ahead and remove it, or I'm going to drop this table, or I'm going to drop this database, because largely they focus on SQL from a SQL Server perspective, and SharePoint's a unique application in terms of how we manage our schema. So we largely have these constraints in place because we want to enforce them, obviously, and it's all due to resiliency. And then if you think about patch management operations later on down the road, again, we take a dependency on our schema in order to apply those patches, cumulative updates, and service packs. So that's why it's so important to just basically treat a SharePoint database as a black box. Don't crack it open, look inside of it. It's tempting from a DBA's perspective to really try to look inside, and I know Brian has done it before, which is largely why we came up with a set of rules. But what we wanted to do is really ensure that from a patching perspective, everything runs smoothly. Because these problems, let's say you do drop a table, or you do add an index, and you apply a cumulative update a year down the road. These problems are very difficult to isolate. as you work your way through troubleshooting those aspects of the product. So that's why we wanted to bring that up as part of this conversation. While we'll be opening some databases, we'll be perusing the tables, we'll be performing some operations against them, we don't recommend generally doing that, but we do want to show you effectively how our schema works and what our databases, SharePoint databases, are comprised of.
That could be one of those RPEs, resume producing events.
That could.
If you modify the table and you update it so much, and then a service pack comes out and the service pack blows up, now entire production is down because you made modifications to the table. Microsoft released a service pack not knowing you tweaked 3, 4, 5 of the basic tables that are provided by SharePoint, and then all of a sudden you can't do the updates, the production's down, and then you have to figure out, you have to explain that to the CIO. Oh, well, I modified a couple tables. Well, didn't you read in TechNet that you're not supposed to do that? Again, it's a possibility of an RPE, so we want to avoid those RPEs.
So just to add a little bit more context into it, we'll talk about some of the imposed limitations, and we are going to speed things up a little bit. We'd like to ensure that we keep things on time, as I mentioned at the very beginning. Unfortunately, Brian likes to hear himself talk, so took up a little bit of time as part of this conversation. But another way to think about SharePoint too is it's really a single data platform. So you install SharePoint Server, and what you end up with is you end up with a product that gives you the potential to have both web content management and enterprise content management within a single data platform. You can have social and core collaboration all within a single data platform. From a planning perspective, what that means is that you can have a lot of different workloads and a lot of different I/O profiles within the same product. And that's unique to SharePoint because it can be deployed in so many different ways and used in so many different ways. So you can go from a read-only web content management solution to a write-intensive collab or social solution, all the way down to kind of a distributed read-write enterprise content management solution. So what you want to think about here is that not all databases are created equal. We don't have a single I/O profile that can really describe SharePoint or describe a single database because they're all used differently. Even two content databases within the same web application can be used differently. You could have orphan site collections or site collections that are rarely used sitting in one content database, and then you can have extremely used site collections sitting in another content database all within the same web application. So not even at the web application level are you going to end up with an I/O profile that's unique to any given web application. So it's a very unique product from that aspect. Again, we have these limitations in place because we want to require consistency and integrity as you apply patches and updates to the product. We have application logic that's very dependent on the schema. So if you think about stuff like a multiple document upload, you think about adding a list item or executing a workflow, all of those have schema implications, or they look to the schema in order to perform their function. That's another reason we don't want you to change it. And then lastly, we use enforced integrity. So we also have some constraints there. But again, the key concept here is it's a single data platform, and you can't really look at it holistically and say there's this overarching I/O profile that's really going to address my SharePoint needs. You really need to understand what you're going to use SharePoint for, and then you'll be able to better understand your I/O profile. And again, unfortunately, your I/O profile will change over time. It's not going to remain static depending on how you use SharePoint. So now what we're going to do, in the interest of time, is we're going to move into some of SharePoint's database descriptions. As Brian mentioned early on in this particular module, we're not going to cover all 23 databases that you assume as part of a complete installation, and that's absent reporting services, which adds another 3. But what we're going to do is kind of cover some of the top databases that you need to think about and plan for as we move into the next module. So I'm going to go ahead and turn it back over to Brian, and he'll hear himself talk for another 45 minutes.
No, I'm going to kind of keep it at least under 40. So we have, as you said, we have 23 unique databases and a complete installation. And what we're going to look at when what our concerns are about those databases are the amount of I/O. We've talked about how important that is, whether it's light or heavy, and also what our options are for improving performance. Do we want to scale up or scale out? So as we talked about, we are going to hit just a few of these. First one, obviously, is the configuration database. All right, so we have options here. Single database stores your farm configuration information. Now you see the I/O pattern on the bottom, and this will be consistent for all the slides. So the I/O pattern on the bottom, 90% read, 10% write. If you needed to for capacity planning, you'd scale up, and it goes anywhere between 0 and 5 gigabytes. And the default name is SharePoint_config. Now when I install anything, if I have the name to database, I always put _DB in my database names. I think you get better performance if you do so. It's totally what I think. But so anytime you name a database, put _DB in the end. That way the processor doesn't doesn't have to figure out, is this a database or not? Because it tells it right on the end of that. So just an opinion.
That's always one of my favorites as well, because it's obviously a database.
Yes.
So you don't really need to call it a database
underscore DB.
within. But as we come back to the configuration database, the configuration database is really what represents a SharePoint farm. I always think about a config database represents a farm. And obviously the configuration database stores a lot of information about your farm configuration, your IIS settings, your farm solutions that are deployed to the environment, as well as some of the topology aspects of your environment. Your configuration database from an I/O perspective is largely read. The predominant amount of write activity occurs when you actually run psconfig and provision a farm, and it provisions the configuration database. As it creates the schema and it adds information and elements to the configuration database, that's where you see all of your write activity. Beyond that, once your farm's created, it's largely read. Unless you're adding servers to the farm or deploying farm solutions, it's largely a read experience. So you really don't need to write optimize for your configuration database. Moving from the configuration database, we move into the central administration content database. So the central administration content database is closely coupled with your configuration database. It's another database that's created when you provision your farm. Again, predominantly read. The write activity is during the provisioning process. It follows the typical naming convention that a generalized content database would, with the exception of, instead of beginning with WSS underscore content, it's SharePoint underscore admin content underscore GUID.
Nice.
Or GUID. Nicely done. And then from a sizing perspective, it can be anywhere from 0 to 20 gigs. And largely this content database won't grow to any extent because you're not adding data to central administration. There is a resources web part, which is effectively a link web part within central administration. I actually use it. I create useful references there. That way I can navigate to central administration and find that data there. I'm going to go ahead and turn it back over to Brian, and he'll talk a little bit about content databases.
Yeah, and the content databases, this is what we primarily use when we're working in the farm. As you can see, the default name is WSS underscore content. What I try to do is use a naming convention, whether I'm creating my IIS website, my content databases. I try to keep it consistent. So if you inherit a farm, you can go into Central Admin, you'll see the name of the web app. You'll go into IIS, you'll see the name of the web app that matches, or the website that matches the web app. And when you go into SQL Server, you're going to see that you have a database out there that matches. So instead of using the default WSS underscore content and having 30 of those with no reference or idea as to what they map to, try to change that out to map to something that's similar. For instance, mine is MTP underscore content underscore DB for better performance. Now, for capacity planning, scale up or scale out, depending on what you're doing, you may want to add additional databases. You may want to increase the size, as we talked about. We can go to 16 terabytes. Remember, we had that soft limit that's about 200 gigabytes, though. Try to keep that in mind and try to keep that as the norm for creating these databases. These are a little bit more write intensive compared to the other two. We had a 90-10 rule for the central admin and for the config database. These are more 80-20. But as Bill has already pointed out, you may have multiple content databases. You may have a database that's holding archived information or historical information that's more read-only, and you may have a database that's more interactive. Transactions are occurring in those site collections. You could have different site collections in those databases to kind of help with the optimization of the user's experience by ensuring we keep those two types separate.
And really, and the way your content database grows, or the way that's used, largely depending on your users. And the way to classify a SharePoint user is there's hunters and there's gatherers. The hunters actually populate the content database with data, and the gatherers are the ones executing queries in order to get the content that the hunters actually created or they trapped and brought home. So there's kind of the hunter and gatherer persona as you think about content databases. Large content databases should really be reserved for kind of single site repositories or non-collaborative I/O patterns and usage patterns. And we talked about that as we talked about some of the database limits earlier. When we talked about the 4 terabyte up to 16 terabyte, largely single site repositories, great example of how you could use a large database. Non-collaborative I/O patterns, so think records management, predominantly read activity as opposed to write activity. So from a write activity perspective, that could theoretically mean that content is created in the content database as an artifact. It is then transitioned to a record center residing in its own content database where it actually becomes a record. Once it becomes a record, it should never be written to again. It should be just a read experience. So again, you have the potential within a single web application to have a variety of usage patterns that represent that web application, and that web application's usage patterns could be significantly different than SharePoint as a whole, because perhaps you have collab or social workloads deployed, so you're using social capabilities. So now you have to think about newsfeed activities, ratings and tags, and all of the ancillary activity that comes with that. Social is obviously more write-related than read-related, whereas collaboration can be predominantly read as opposed to write. So you generally read more content than you actually produce. If you're producing a bunch of content but not reading it, then obviously something's not working right.
Yeah, so what we're going to do now, we've got, as you can see, you can kind of see the format. So this is the user profile application, the profile database. We've got 3 of these. We've got 4 search. We're going to just shuffle these to the end, so they're going to actually be in the appendix, so they'll be available. But you get the general idea. We give you the default name, capacity planning, whether you're going to scale up, scale out, and the range that you'll want to work with, and then the I/O pattern, whether they're read intensive or a combination of read and write. And we've explained to you some things to take into consideration when you're kind of planning for your databases and the size of your databases. So what we'll do is we're going to kind of wrap up this module here and set up for a 10-minute break, and we're going to make sure you'll have every database for every service application will be available to you. So in this section we went through the SharePoint deployment. Remember, try to have a dedicated instance of SQL Server. Remember, they're sharing resources on that physical server though. You want to have a unique, as far as unique SharePoint database schema, don't modify it, because that could be an RPE. We want to avoid RPEs. You want to make sure that it's available or capable of handling any cumulative updates or service packs. And lastly, is we started just to touch the surface on creating service applications. There's databases, at least one database for almost every service app. UPA has 3, Search has 4, and we went through the common ones like a content database, and we went through the config database and the central admin content database. So we're going to break for about 10 minutes, and we'll return in 10 minutes, and we'll go into the next section where we're going to talk about how we're going to modify and customize some databases, specifically Model and TempDB in SQL Server for optimizing SharePoint 2013.
So again, this module was largely an introductory module. We wanted to kind of lay the framework for the remaining 3 modules that are going to come throughout the course of today's presentation. So the way to think about this module is definitely reference back to it. Again, we'll talk a little bit about pages and extents and tables and data units and indexes and rows, row wrapping, name value pairs. We're going to get a little deeper into that as we work our way through. And then hopefully the next module will keep on time, providing that Brian talks less about himself and more about what we're actually doing here today.
Did I tell you I got my hair cut the other day? Oh, never mind. We're offline.
They went a little short.
Okay. Yeah.